guys, what's up? It's Eric with Advanced Love Automotive. Welcome back to another video. Welcome back to another case study. Right behind me I have a 2014 Lexus LS460. The vehicle just got towed in. It is a no start, but before I go into details, let me explain to you the context behind why this vehicle is here. Now, as many of you know, we are located in Houston, Texas, and down here in Houston, Texas, we have a lot of flooded vehicles. This Lexus right behind me is one of them. Now, I'm no stranger to flooded vehicles. Being a specialist in electrical, after Hurricane Harvey hit in 2017, I dealt with a lot of flooded vehicles that had a lot of electrical problems. Now, what I've learned from my experience in dealing with flooded vehicles is that a lot of them are not worth saving, especially when it comes to luxury vehicles. That includes BMW, Mercedes, Audi, and cars like this Lexus right behind me. The problem with a lot of these luxury vehicles is that they are overcomplicated in their design. And what I mean by that is that they have a lot of electronics. Some of these cars can have upwards of 50 to 60 computer modules on the vehicle. Getting water in these computer modules can get really expensive, especially if you're having to replace multiple ones. And even after you get the vehicle running, it's still going to continue to have problems down the road. With that being said, let me explain to you why this vehicle is here. This vehicle came in from a different shop. And at the other shop, they've already attempted to replace multiple different modules. They also disconnected a lot of the wiring harnesses to try to clean up a lot of the corrosion that was in there. They've already done some testing and some poking around. So on top of this being a flooded vehicle, this is a flooded vehicle that came in. Somebody's already been messing with it. I don't know what's disconnected, what's connected, what's missing, because I wasn't the first person to work on the vehicle. That in of itself is a lot of the reasons why I wasn't even really sure if I was going to take this vehicle in to try to fix it, because a lot of times with these vehicles, we spend way more time than we can bill for. Now, with that being said, hopefully you guys understand why I wasn't sure if I was going to continue with this vehicle and why I wasn't even sure if I was going to make a video about it. Now, I talked to the customer, I explained to him my side of the story, and as long as they understand, I'm willing to give it a shot. Plus, this might be a perfect opportunity as a learning experience, not only for you guys, but for me as well. So with that being said, hopefully you guys stick around, enjoy the video, come down this rabbit hole with me, see if we can figure out our way out, and we can become more knowledgeable of how these complicated systems work on these vehicles. So without further ado, let's get started. All right guys, so let's get started with a quick overview of what the car is doing and what's wrong with it. So first of all, the battery is dead. I do have the battery charger on. As you can see, this is the way the vehicle came in. I mean, just already looking at a lot of this stuff, looks like there's some oxidation. I don't know if that's because the vehicle's been sitting for a few months, or that's an indication of maybe how high the water got. I'm not really sure, but let me show you inside the vehicle. The vehicle just got towed in, and as you can see, the previous technicians that were working on it left a lot of things disconnected. So again, I'm not really sure what's connected and what's not, but there's a lot of wiring disconnected and hanging out. So as you can see, a lot of the trim panel pieces are sitting over there, and if you look on the seat, you've got a couple of the different modules that I guess these are the ones that they removed and replaced. There's also a box here with another module that I believe they replaced. So we have some different modules laying on the seat over here. Again, I'm not really sure where these modules go or where they came from, but if I'm not mistaken, I believe these are the ones that they already replaced. So the other issue that they're having, if you didn't notice, this seat is actually leaned all the way back. Now, I've seen this happen with flooded vehicles. If you look at the passenger seat, you'll see it's leaned all the way back also. So I'm not really sure how high the water got, but the water got high enough to get to the seat electronics down here, and it caused them to short circuit. So I believe what started happening is that when the water got to the electronics of the seats, they actually started folding back. And when they started folding back, they actually reached a point to where they hit the back seats, where they wouldn't go any further down. So I've seen a couple of these. I had one BMW that it actually went back so far that it actually ended up breaking the hinge on the seat. So anyways, aside from the no start condition, that's also something we're gonna have to try to fix, are the two seats that no longer work. So let me go ahead and clear these modules off of the seat so I can get inside the vehicle and show you what's going on. All right guys, so we are inside the vehicle. Let me go ahead and quickly show you what the main complaint is. I have the key right over here, and as you can see, this is a push start ignition. Now I'm going to go ahead and put my foot on the brake pedal. Now, one funny thing I do notice is that if you hear that, the vehicle actually is beeping when I push down on the brake pedal, but I'm going to go ahead and push the brake pedal down, and I'm going to try to start the vehicle up. As you can see, nothing is powering up. Hopefully you guys can see the instrument cluster. Sorry about the position of the steering wheel, but the instrument cluster is not lighting up. This display is not lighting up. Nothing inside is coming on. Even without my foot on the brake, if I take my foot off the brake, I should be able to at least turn on the accessory mode by just pushing this button and power up the interior, but nothing is powering on. Now, I did notice that the lighting system does work, so if I use the hazard switch, turn them on, you'll see that the hazard lights do come on. Also, if I turn the headlights on, the headlights do come on. Hopefully you guys can see me turn the headlights on. Right there, as you can see, the headlights are on. Turn them off. So the headlights are working, hazards are working, turn signals are working. Pretty much the lighting system, the interior lighting system is working. So if I turn the spotlight on, you'll see that these spotlights work. So we do have electricity to the lighting system inside the vehicle, but we don't have any ignition powering up. So that's going to be the main thing that we're focusing on. We're going to see if we can get this ignition switch to turn on. We're going to see if we can get the vehicle to start. All right, so I think before we go any further, I think the first thing I want to do, because I noticed that down here there was a lot of connectors that were left disconnected, I guess by the previous technician. So I'm going to go through, reconnect all of these connectors, and then we're going to see if we can start it. All right, guys, so I pretty much had to go down here and reconnect everything because all of this stuff was disconnected. I'm not sure if there's a reason why they left everything disconnected, but there was multiple different harnesses and connectors that were left just disconnected. Anyway, we have it all reconnected, so let's go ahead and give it another shot. And as you can see, nothing's happening. I'm going to go ahead and put my foot on the brake. You hear that beeping noise? I'm not really sure why it's beeping when I push on the brake. I'm going to go ahead and push the start button. Still not doing anything. All right, guys, so contemplating our next step. I mean, there's really no wrong way of doing these things. I was thinking that probably the next thing we could do is, you know, come under the hood and check the fuses with just a simple test light like this. That's normally what I would do. But the truth is that this vehicle has a lot of different fuses. This is not the only fuse box located on this vehicle. We also have like 3 other fuse boxes inside the vehicle. And then also we have this, not only this fuse box here, which if I lift this cover up, you'll see there's some fuses and relays there. I think there's this right here. No, that's some connectors. But we have this, it looks like some type of main feed fuses. If you look down in here, this is the battery cable going to this block of what looks like main fuses that kind of feed everything else. Now, the problem with just kind of going through and checking these with a test light is that, first of all, we can't even turn the ignition switch on. So if we can't turn the ignition on, we can't power up a lot of the circuits that are running through this fuse box anyway. So we could go down the line, check these fuses, and a lot of them are not even going to be powered up. Now, there's nothing wrong with checking the fuses. I'll probably do that anyway. But all I'm saying is that as we're checking the fuses, we're going to find that a lot of these don't even have any power going to them. So what we need to figure out is if we're missing power to certain circuits, where is that power coming from? Now, obviously, we're missing something that's powering up the inside of the vehicle as far as the ignition goes. Now, the other thing we could try to do is maybe hook up a scan tool, but I'm not even sure if we can really communicate with the scan tool because we can't even turn the ignition on. So, I mean, it's worth a try and it doesn't hurt to try. So let me go ahead and hook up the scan tool and see if we can get any communication. All right, guys, so moving inside the vehicle, as you can see, the OBD2 connector is right here. I've got my J-box for the Maxi Sys. I'm gonna go ahead and connect this. And as long as we have good power on pin 16, this should light up. As you can see, power source did light up. So there is power on pin 16 for this thing. Let's go ahead and check the scan tool. All right, so moving over to the scan tool, let's go ahead and do an automatic selection. Read the VIN. Again, like I said, I'm not even really sure if this is going to work because we cannot turn the ignition on. So we may not even be able to communicate with this thing. All right, so as you guys can see, VIN reading failed. That's kind of what I expected. I didn't think that we were even going to be able to communicate with this thing. Like I said, if we can't turn the ignition on, we're not able to power up the computers. We're not able to power up most of the electronics that we need to check. So I think what I want to do next is I want to get a little more specific into what we're going to check. And what I mean by that is let's go ahead and move over to the wiring diagrams. Let's get a better idea for how this system works, specifically for how the push button works, how the ignition powers up inside of the vehicle to wake up all of these modules. And after we have a better understanding, then we can come back and we can check whatever needs to be checked. So like I said, I mean, it may be a problem with one of these main fuse feeds, or it could be a problem with one of these relays. I mean, it could be a problem in multiple different areas. So what we need to do is we need to get a little bit more specific, and the only way for us to get more specific in our pinpoint diagnostic is to better understand how the system works. So let's go ahead and move over to the wiring diagrams. All right guys, so moving to the wall inside my office, what I went ahead and did was print up the power distribution wiring diagram. As you can see up here at the top, it involves 1, 2, 3, 4, 5, 6 different pages. And what I did was I stapled them all together, put it up on the wall just to make it easier for us to see. Now, if you can guess, this wiring diagram is pretty complicated, but before we get into it, let me give you an overview of the modules that are on the vehicle, because if we look up at the wiring diagram, if you look at these gray areas, these gray boxes, these are different modules and different fuse boxes. And before we get into it, I want to be able to show you them on the vehicle, that way we can differentiate what they are. So if you look down over here, I've got some pages printed up. If you look over here, this is the inside of the vehicle, this is the dash. And if you look, of course, we have the combination meter, which is the instrument cluster. And here inside the vehicle, on the driver's side and on the passenger side, is where you'll find 2 different modules. Now these modules are also fuse boxes. So it may seem a little bit confusing when we go into the vehicle and see these, they look like fuse boxes, but they're actually computer modules. So just to get the terminology right, the one on the driver's side is called the main body ECU, driver side junction block. The one on the passenger side is called the electric power control ECU on the passenger side. It's also called the passenger side junction block. Now moving under the hood, you'll see that we have some components over here that we need to note and understand the terminology for them. So right here along the driver side fender, you'll find the ECM, engine control module, and then you'll also find a couple fuse boxes. Of course, you'll see this is the battery, where the battery was located. There's also the battery current sensor that's near the battery. But if you look up here, this right here is called the engine room number 1 junction block, relay block. So this is the number 1 fuse block. And then if you look over here, this is going to be the number 2 relay block. So there's 2 engine room junction blocks, number 1 and number 2. These are going to house several different relays and fuses. Now there is another module slash fuse box in the luggage compartment in the trunk, which I don't have it pictured here, but I'll show it to you on the vehicle, which is what we're going to do next. What I want to do next is I want to show you on the vehicle where each of these modules is located. That way we have a better visual representation of what we're looking at before we just dive straight into the wiring diagram. So let's go ahead and move over to the vehicle and I'll show you where these things are located. All right guys, so moving back under the hood, looking at the diagram, as you can see, this is going to be the fuse box number 2 right here. So number 2 fuse box, and the number 1 fuse box is going to be this one up here. This is the one that I was saying has the high amperage fuses. If you look in here, maybe I can pop this cover off here. Let me see. Let me get a pick tool. All right guys, so using a pick tool, I was able to just pop this off right here. Now you can get a better look at the fuses that are inside. So if you look, you'll see that these are high amperage fuses that come directly from the battery cable here. Now taking a visual look at these, I don't see any of them that are burnt. They all seem to be connected. So that's one thing that we're going to want to check. But anyway, that's going to be fuse box number 1. This is fuse box number 2. Let's go inside the vehicle and let me show you the modules. All right, so moving inside the vehicle, before we go in there, again, taking a look at this diagram, you'll see that on the driver's side here, we have the main body ECU, also known as the driver side junction block. Let me show you where it's at. So we're on the driver's side over here, looking underneath where the kick panel's at over here. If you look up, it looks kind of a mess down here, but you'll see this fuse box. Let me move some stuff out of the way. So you see the fuse box here. We have a number of different fuses, and there's a bunch of connectors on this box. So this right here is a junction box on the driver's side, also known as the main body ECU. All right, so I went ahead and just kind of popped this panel off right there so we can get a better view of it. But this right here is the main body ECU. And actually, if you can see, it looks like they've already replaced it. It says warranty void if seal is removed or broken. So this does look like a replacement part. Like I said, It is a module slash a fuse box. So you can see the fuses there. Now let me go ahead and show you the one that's on the passenger side. All right, so moving over to the passenger side of the vehicle, if we look down here underneath the glove box, you'll see it kind of hanging there. I mean, these modules are supposed to be bolted in, so it looks like, again, like I said, somebody was already messing with this, and if I'm not mistaken, I believe they've already replaced this one. But if you see, it's also a fuse box. It's got a bunch of connectors on there. So this is the one that's on the passenger side, and it's referred to as, turn this around. The one on the passenger side is referred to as the electric power control ECU. So anyways, that's an overview of the modules. Well, there's also one more in the trunk. Let me show you that real quick. Now moving over to the trunk area, if we move this panel over here, you'll see that we have another fuse box way down there. Hopefully you guys can see it. There's another fuse box down there slash module. Oh, there's a hole access right here for this. So I don't know if this one's been replaced or not, but you can see it right through this access hole. That's going to be the one in the luggage compartment. The other module I forgot to mention under the hood is going to be the ECM. Looking at this diagram here, you'll see that it looks like it's actually located in this box over here. So it's got a few 10mm bolts around the box. Let me see if I can get this lid off. All right, so I zipped the bolts off of that lid. Let's go ahead and see if we can pull it off. There you go. And there we have it. This is the ECM. Looks like somebody's already been messing with it because it's not bolted down. But I don't know if they replaced it or not. But everything looks like it's connected. I see two different modules actually. So there's another one down here. I guess I'm not really sure which one is the engine control module. This one says ECT. The other one we can't even get to it, so. But anyway, just so we know, those are the modules that are located there. Let's go ahead and go back to the wiring diagram. All right guys, so now that we have an overview of where the modules are located on the vehicle, hopefully that helps you to better understand the wiring diagram. That's why I wanted to do that before we just jump straight into the wiring diagram. So again, looking at an overview of this wiring diagram, if you look at the gray boxes, the gray areas, these are actually the different fuse boxes slash modules. Now the one thing that Toyota did not do on this wiring diagram is label any of these gray boxes. So I actually had to kind of go in here and look at all the different fuses and find where they were located on the different modules, and then I just wrote them in myself. So if you look, this gray box over here is fuse box number 1, which is the one under the hood, which is this one right here where all the main fuses are. And then if you look over here, I just wrote passenger side junction box. That's going to be the one on the passenger side. That's also known as the electric power control ECU. We're just going to call it junction box, passenger side and driver side, just to make it easier. So I'm not referring to it as electric power control unit or main body ECU. We're just going to call it driver side junction block and passenger side junction block, just for the simplicity of it. So if you look over here, I wrote passenger side junction block. Over here I wrote driver side junction block. This turned out to be the luggage junction block. This is fuse box number 2, which is this one right here under the hood. And then going back over here, you'll see this is right here the main body ECU, which is also known as the driver side. This right here, main body ECU, driver side junction block. So that's going to be the main body ECU slash driver side junction block. And then this right here is the power switch, which is a switch inside of the vehicle that you use to turn the ignition on. Looking over here, you'll see the driver side junction block again. It's got the fuses and relays. Looking over here, you'll see the passenger side junction block, and then you'll see the luggage junction block over here. So with that being said, what I want to do is I want to kind of focus in on the start and stop switch along with the main body ECU, and then just kind of move out so that we can understand this wiring diagram a little bit easier. So without further ado, buckle up guys, let's get started. All right guys, so let's start by zoning in on these two components right here. Again, we have the main body ECU located right here, and we have the power switch. Between the two components, we have these two wires. We have a blue wire, and then we have a white wire. The blue wire is designated as SSW2, and the white wire is labeled as SSW1. Now what these wires do is they carry a reference voltage. Now this reference voltage is being sent by the main body ECU to the power switch. So we have a reference voltage coming out on this blue wire and a reference voltage coming out on this white wire. Now these two reference voltages get to the power switch here, And what happens is that we have two different positions on the wire switch. We have the free position, which is when you're not pushing it, and then you have the full travel position when you're fully pushing the button. When you push this button, what you're doing is you're grounding the two circuits. So if you take a close look, you'll see that we have this dot right here lining up to the white wire, and then we have this dot right here lining up to the blue wire, which is connected to this ground wire, which is this white wire. If you follow it out, you'll see that we have a couple grounds here. So that's how this switch tells the main body ECU to turn the ignition on. Now, when you push this switch, several things happen with the main body ECU. Let me explain. Now, if you look up here, you'll see that we have three different wires. We have this Accessory D on this green wire. We have this Ignition 1D on this violet wire. And we have this Ignition 2D on this pink wire. Now, what happens when you push this power switch is a couple different things. First of all, we get a power that gets sent out from the main body ECU. So the main body ECU is going to send an ignition power feed out on this violet wire. Now, if we follow this violet wire out, you'll see that it goes to the driver's side junction block, which, funny enough, even though it's drawn up as a separate thing, this is actually the same as this. These are not two different components. They're just drawn up that way. And to be honest with you, the relays that are located on this thing are not even real. They're drawn up like this, but in fact, these are solid state relays that are built into the module. So these relays are drawn up like relays, but they're not physical relays that we can take out and replace. These are actually solid state relays that are built into the module. So just to get that straightened out, these two components are actually the same thing. So anyways, we get a power feed that comes out on this Ignition 1D on this violet wire. Again, that power feed goes back to itself, funny enough, the driver's side junction block. And if you look inside, you'll see that this power gets spliced off. But if we follow it this way, you'll see that it powers up the control side of this D Ignition 1 relay. Now, if you look at the other side, the splice, it goes out to a ground. So when a power feed gets sent through here, it's going to energize this relay, close this switch, and that's going to send a power feed throughout all of these fuses, which feed several different circuits on the vehicle. Now, if we follow the splice out this way, you'll see that it goes to the passenger side junction block. And over here on the passenger side, you'll see that we have this P Ignition 1 relay. So this is going to be a power feed for the control side of that relay. You'll see that there's a ground over here. So that's how this relay gets energized. Now we have another splice in here where that power feed gets spliced off back over this way. If you follow it up, we'll follow it along to this page over here, and we reach the fuse box number 2. Again, fuse box number 2 is going to be this fuse box right here. Not the one that has all the high amperage fuses, but the other fuse box. So again, moving back to this violet wire, that power feed is coming in on this violet wire. If you follow it around here, we go to the Ignition 1 relay. Now this is an actual relay. This relay, we can pull it out and we can replace it. Now if you follow this power as it's coming out of the control side of the relay, you'll see that it comes down here, and this is where it looks like it gets a little bit confusing, but don't let this confuse you, because if you see, it looks like there's a splice, and you would think that that power gets spliced up to the control side of this Ignition 2 relay, but that's not what's happening here. If you look, this splice, along with these other splices right here for these other relays, are actually a shared ground. So if you follow, again, the splice and this wire goes off to these white and black wires. Now these white and black wires, if you follow them out, these are constant ground. So these are either body grounds or some type of ground that's always a constant ground. So again, follow the power that comes out of the relay. This is always going to be a ground because it's a constant ground. So as soon as power gets sent in from the violet wire, that energizes this relay, closes this switch right here, and then sends power out to all of these subsystems right there. So hopefully that makes sense. Now if we go back to the main body ECU on this pink wire, you'll see Ignition 2D. If we follow this pink wire out, you'll see it goes over to the fuse box again, number 2, but it goes into the Ignition 2 relay. So you'll see the power come in on this pink wire, power comes in. Again, this side is a constant ground through these white and black wires right here. So as soon as power comes in on this pink wire, that's going to energize this relay, close this switch, and send power out to these different sub-circuits right here. So hopefully that makes sense. Let's move back over to the main body ECU and let's look at Accessory D. Now Accessory D is also going to be another power feed coming out of the main body ECU, and if you follow it over on this green wire, it's going to go again back to itself because the driver's side junction box is the same thing as the main body ECU. I know that's confusing, but these two components are the same thing. Anyway, power comes in on this green wire. You see it feeds power to this D accessory relay, which gets its ground through here, through this white and black wire. So once power comes in, that energizes this relay, closes this switch, and sends power out to these fuses. So hopefully that overview makes sense to you guys. And now that we understand this, I mean, there's several different things that we can check. First of all, we can probably go to the power switch because it's easy to get to. We can find this white and blue wire, and we can see if we're getting a reference voltage from the main body ECU at the power switch. And as long as we push the power switch and this ground is good, we should be grounding these two reference voltages, which should signal this main body ECU to turn on power to these ignition feeds right here. So the other thing we can do is probably go to the fuse box number 2 right here, and we can locate these ignition relays, ignition 1 relay and ignition 2 relay, and we can check to see if we're getting the power feed on pin 1, which is again the power feed that comes from the main body ECU, feeds the ignition 1 relay, and then the power feed on pin 1 for the ignition 2 relay, which is the power feed that comes from the pink wire, which comes from the main body ECU. So if we're seeing power at these relays right here, then we know the main body ECU is doing its job and it's sending out power to the ignition relays. So there's several different things that we can check. Again, there is no wrong way to do this. It's probably just, let's try to do the simplest thing first. All right guys, so moving back inside the vehicle, I've already popped the switch out using a plastic trim tool like this. And if you look at the back side of the connector, the 3 wires that we're dealing with are going to be these 3 wires down here, pin number 2, pin number 5, and pin number 7. The 2 reference voltages are going to be the pin number 2 and pin number 7, and pin number 5 should be our ground. So I got a back probe tool right here. I'm going to go ahead and back probe pin 2, this blue wire. So we should have some type of reference voltage on this. Got my power probe right here. I'm just going to stick it in there and see if we have a voltage. All right, now looking at the power probe, as you can see, I'm touching the back probe tool, and we have 11.3 volts on that wire. Now this 11.3 volts should become a ground if we push the switch. So I'm going to go ahead and push the switch. As you can see, my meter is grounded. I'm going to let off of the switch. We get our voltage back. I'm going to push the switch again. You see we have a ground. So that does mean that the reference voltage, at least on this pin 2, is getting from the main body ECU, which is down over there. It is getting to the switch, and the switch is grounding it. Let's go ahead and check the other wire, which is pin number 7. The white wire should be our other reference voltage. Let's go ahead and touch that one. All right, so I've got my back probe on pin 7, and if you look at the power probe, you'll see we have 11.3 volts, which is the same thing that we saw on the other wire. So that means that the 2 reference voltages are getting to the switch, and when I push the switch, we should see a ground. So I'm going to push it. Damn it. I'm going to go ahead and push it. As you see, we have a ground. I'm going to let off. We get our power back. I'm going to push it again. I'm going to let off. All right guys, so what that's telling us is that the 2 reference voltages from the main body ECU are reaching the switch, and the switch is working. It is grounding those 2 reference voltages. So there is a signal that is reaching the main body ECU that's telling it to power up the ignition. So I guess the next thing we need to do is we need to check to see if it's powering up the ignition. All right guys, so just to explain, we did verify that the 2 reference voltages from the main body ECU are reaching the switch. And when we push the switch is working, and it is grounding the 2 reference voltages. So this main body ECU knows that we are pushing the switch. Now, what we need to find out is whether or not this main body ECU is powering up these ignition circuits right here. So probably the next easiest thing we can do is go over to these ignition relays that are in the fuse box. Again, we're going to go to fuse box number 2, which is this one right here under the hood. And we're going to find ignition 1 relay and ignition 2 relay. So if everything is working, if this main body ECU is powering up, it's going to be sending out a voltage, and we should be getting a voltage on pin 1 of ignition 1 relay, and we should also be getting a voltage on pin 1 of ignition 2 relay. Now of course, relays are going to have 2 different power sources, so we are going to have one constant power on pin 5 right here, and also pin 5 right here. If we follow that power source from pin 5, you'll see that it comes through this white wire that actually comes from this main fuse block right here. So if you see, the fuse that feeds it is going to be this engine room 1 fuse. So this 80 amp fuse feeds power to this fuse box right here, which powers up this relay. Now on the same note, on pin 5 of ignition 2 relay, we should have a power feed that comes from this black wire. If you follow it out, it also goes to another one of these high amperage fuses, this 80 amp EFI fuse. That's what feeds the ignition 2 relay. So again, we're gonna go to these relays. We're gonna make sure that we have voltage on both pin 5 and also on pin 1. Now pin 1 voltage should only be whenever the ignition switch is on. So let's go ahead and check it out. All right guys, so moving back under the hood. Again, we're at the fuse box over here. These two relays are gonna be the ignition relays. This is ignition relay 1 and ignition relay number 2. Now I do have a layout over here, and if you look, again, ignition 1 relay and ignition 2 relay. If you look, we have pin 5 and pin 1, pin 5 and pin 1. Let's go ahead and pull these out and see if we have power. All right guys, so I got the relays out. And let me tell you, these were not easy to get out. I mean, they were stuck in there so much that this one, actually, the cover came off, though. Oh, that did hit the ground. Anyway, the cover came off, but it doesn't look like it damaged the relay. The relay still looks okay. This one I was able to get out without breaking it, but man, they were just stuck in there. Anyway, looking at the layout over here, this is going to be number 5 right here. Those are going to be the power feeds that are coming from the main fuses over here. And then pin number 1, this one right here, and this one right here. Pin number 1 is going to be the power feed that's coming from the main body ECU. So I've got the power probe right here. Let's go ahead and check for voltage on pin number 5. So we have pin number 5 here. I'm not pushing in on the terminal. I'm just going to lightly touch it. We're going to see if we have power. So you can see we have power there. I'm going to go ahead and check pin 5 on the other one. We have power there. So that means that the power from the fuses over here are getting to the pins on the ignition relays. Now let's check pin number 1 on both of these. All right, so pin number 1, I'm showing a ground, so we don't have voltage there. Pin number 1 over here, I'm also not showing any voltage on pin number 1 on this one here. Now, the interesting thing here is that when I touch it here, I show a ground, and over here, I don't show a ground. So I don't know if that means that there might be a continuity problem between this one and the main body ECU, possible, but I think the next thing I want to do is go straight to the main body ECU and check to see if we have power coming out of there. All right, so hopefully you guys are following along. If you recall, what we just did was we found these two ignition relays, ignition relay number 1 and ignition relay number 2. And what we were looking for were two different power sources, the power source on pin 5 and the power source on pin 1 on both of these relays. What we found was that we did have power on pin number 5 on both of these relays. Again, pin number 5 is the power feed that comes from the high amperage fuse box. If you recall, there's the high amperage fuse box that has this 80 amp fuse, and then also for ignition relay 2, pin number 5, if you follow it out on this black wire, goes back to this high amperage 80 amp fuse. So what we know is that the fuses in this high amperage fuse box are good, and the power is getting to these two relays. But what we found was that the power on pin 1 on both of these relays were not reaching the relay. Now the power on pin 1 comes from the main body ECU. If you recall, on the violet wire, this power coming from the main body ECU goes to pin 1 on ignition 1 relay. This power is not there, and also on ignition 2 relay, pin 1, the power comes from this pink wire, which comes from this main body ECU. So what we need to distinguish is whether or not we have a problem where the main body ECU is not sending out a voltage on these wires here, or it's possible that it is sending out a voltage, but there's a problem in the wiring integrity between the main body ECU and the fuse box that's under the hood. So I think the next thing we need to do is we need to go inside the vehicle, go over to the main body ECU, and we need to back probe these wires and check to see if there's power coming out on this ignition 1D and ignition 2D. The way we're going to do that is I have the connector pinouts right here. Now if we go back to the main body ECU, you'll see right up here it says L12, also designated as connector B, and L13, also designated as connector C. So if you look at these wires individually, you'll see that they either say C or B. That's referring to either the L12 or the L13 connector. Now I have the pinouts for both connectors right here, L12 and L13. And what I did just to make it easier is I wrote in B and C to help us distinguish both. Now on connector B, what we're going to be checking is for the pink wire for ignition 2D. Now that pink wire is pin 11. If we go over to the layout over here, you'll see pin 11, and I wrote in pink because that's the color of the wire that we're looking for. Now the other thing that we are going to check, because this is really important, are these AM1 and AM2. The reason we're going to check AM1 and AM2 is because these two are power feeds that come into the main body ECU, and these power feeds need to be here in order for this main body ECU to function. So if you follow these wires back, there's two white wires. You follow them back, you'll see that we have this AM2 fuse right here. It's a 5 amp fuse, and this fuse is actually located in the passenger junction box. So we could go over here and check the fuse, but the truth is, while we're here doing the pinouts for the connectors, we may as well check to see if the power is there, because it is possible that the fuse is good and there's power coming out of the passenger side, but that power from the passenger side is not reaching the driver's side. So it's easy enough to just go ahead and check to see if we have power on both of these two terminals right here. If we have power on both this AM1 and AM2 power feeds, then we know that everything between the main body ECU and the passenger side junction box is good. We won't have to worry about that. So again, we're going to be checking on connector B, pin 1, which is going to be the AM2. So we're going to be looking at pin 1 right here on the connector L12, also labeled B, pin 1. Again, it's going to be a white wire because that's what it says up here. And then over on the other connector, which is L13, also known as C, we're going to be looking at pin 22, which is this Accessory D power feed. We're going to be looking at pin 3, which is this ignition 1D power feed. So if we look at the diagram down here, you'll see L13C. We're going to be looking at pin 3, which is the violet wire. We're going to be looking at pin 6, which is the white wire. Then we're going to be looking at pin 22, which is the green wire. So let's go ahead and go over to the main body ECU and start back probing these. All right, guys, so moving back inside the vehicle. As you can see, I've already located the two connectors. This is the main body ECU. And if you look, this connector here is L13, and this connector here is L12. As you can see, I've already got two T-pins back probed on two different wires. Let me show you the first thing I want to check. I've got the pin layout down here just so I can show you. The first thing I want to check are going to be the two power feeds that come from the AM2 fuse. Again, these power feeds are really important because without them, this main body ECU cannot function to give power to the ignition source. So we're going to be checking these two wires. Again, it's going to be pin number 6 on the L13 connector, which is a white wire, and pin number 1 on the L12 connector, which is also a white wire. So those two pins should be power feeds. Again, that power feed comes from the passenger side fuse box. So as long as the fuse in that fuse box is good and the wiring integrity between that passenger side fuse box and this main body ECU is good, we should have power on both of these two T-pins. So I've got my power probe right here. We're going to go ahead and touch the two T-pins and we're going to see if we have power. And as you can see, we're actually showing a ground. Let me touch the other one. And we're showing the same thing. So we actually don't have our voltage power source getting to the main body ECU. What we need to do is we need to trace down why we don't have power at the AM1 and AM2 on these two connectors. So let's go over to the passenger side and check that AM2 fuse. All right, guys, so moving back over to the passenger side, we've got the passenger side junction box right down here. So you can see it's got all the fuses. I have a diagram with the fuse layout, and if you look right over here, we have this 5 amp AM2 fuse that's right above this big 30 amp fuse. So let's go ahead and check it. It's going to be this one right here. Got my power probe. We're just going to touch each side of the fuse and we're going to see if we have power on both sides. So as you can see, we don't have power there. We have a ground. Let's touch the other side and check that out. Looks like we have power on this side, but we don't have power on this side. So that's definitely looking like a blown fuse. Let me go ahead and try to pull it out. Let's see if we can get a close look at it. Yep, that's definitely a blown fuse. Hopefully you guys can see that. Let's go ahead and replace it. Alright guys, so I went ahead and installed another 5 amp fuse in there. let's go ahead and move back over to the driver's side. All right, so moving back over to the driver's side, I've got my T-pin on one of the white wires for the AM2. Let's go ahead and check and see if we have power now. As you can see, we have power on that one. Now let's check the other one. All right, so I've got the back probe on the other AM2. Let's check to see if we have a power feed there. And as you can see, we have power feed on both of those now. Let's do a quick check and see if the ignition turns on. So let's go ahead and try to push the button. And still nothing's happening. So we definitely had a blown fuse on that side, the passenger side junction box with that AM2 fuse. We went ahead and replaced that fuse. Now we have power over at the main body ECU, but we're still not powering up. So let's quickly check to see if we have output on those other wires. All right guys, so the first wire I'm quickly going to check is going to be pin number 3 on the L13 connector. Again, that's the violet wire. We should have power on that wire whenever we push the ignition on. So if we check it right now, I've got my T-pin on there. I touch it, you can see we don't have any power there. I'm going to go ahead and try to push the ignition switch. Again, nothing's coming on when I push this switch, so I doubt that we're going to have any power there, but push the ignition switch. Let's see if we have any power there. And we still don't have power there. So there's definitely still a problem. I'm not sure if there's a problem maybe with the main body ECU, because remember, we've already verified that this switch is working because it is grounding the 2 reference signals coming from the main body ECU. So the main body ECU does know that we're trying to turn on the ignition, but it's just not powering up the circuits for the ignition power. So let's go ahead and check the other ones while we're here and see what we have. All right guys, so quickly, the next one we're going to check is going to be pin 11 on the L12 connector, which is the pink wire. Got my power probe here, and I have the T-pin back probing the wire, so I'm going to go ahead and touch it. And we don't have any voltage there. You can see we're showing 0 volts. I'm going to go ahead and push the ignition switch. Check it again. And we still don't have anything there. So I mean, there's one more we need to check, which is going to be the green wire. That's going to be the other ignition feed, but that's for the accessories. Again, I doubt that we're going to see any power there, but while we're here, let's go ahead and check. All right, so I have my back probe on the pin 22, which is a green wire. Let's go ahead and touch it. And we don't have any power there. Again, let me go ahead and push the ignition switch. Nothing happens. Let's double check it. We still don't have any power there. So I think the next thing we probably need to do is check for any main inputs to the main body ECU. So I think the next thing we need to verify is whether or not we have a problem with the main powers or the main grounds for this main body ECU. So let's go back to the wiring diagram and see what we can figure out. All right guys, so before I move any further, there is a quick check that I want to do. Let me show you what I got set up over here. So if you look, I've got my 3 leads on the 3 back probes that I have. So the 3 back probes that we're on is going to be the 3 wires coming out of the main body ECU. So we're looking at the violet wire, the pink wire, and also the green wire. So we already know that the main body ECU is not supplying that voltage to the rest of the system. So, and what I wanted to do was see if I could power up that circuit manually. And the only reason I'm doing this is because what I want to verify is whether or not we have any other subsystems that are being affected. Again, if you guys remember, this car was underwater, and I believe this water got up pretty high. At least we know it got over the seats and it got up into this area of the dash. So a lot of these electronics could be compromised. Not only that, but the wiring could be compromised as well. So what we want to do is we want to verify whether or not, if we fix or replace this computer module, will everything even power up? So that's what I want to verify, because it could be that this module is only one part of the rest of the system that has a problem. So what I'm going to do is I'm going to use the power probe and I'm going to send a power feed through those ignition wires. And hopefully when I do that, as long as everything as far as the wiring integrity from this computer to the rest of the vehicle is good, we should be able to power up the interior of the vehicle. So that's what I'm hoping to do with this test. I'm going to be using the power probe here. And if you're worried about it, I mean, this thing has a built-in circuit breaker. I believe it's rated somewhere around 8 amps. So if there is a short circuit somewhere in the wiring or somewhere in the vehicle, this circuit breaker will blow. So what I'm going to do is I'm going to send a power from my power probe and into those ignition wires. So let's go ahead and see if we can power this thing up. Again, I've got the test leads on the tip of the power probe here. I'm going to go ahead and flick this rocker switch and provide a power. Check that out. As soon as I did that, you can see I'm providing a power with the power probe, and as soon as I did that, the inside of the vehicle powered up. You can see that screen. There's the navigation. Looks like everything on the instrument cluster is powered up. Looks like everything inside is working because I am providing a power manually to those individual circuits. All right guys, so like I said, now that I'm providing a power to those ignition sources, we are able to power up the inside of the vehicle. And one of the quick things I want to try to do is I want to see if we can maybe start the vehicle. So let me just get situated here. Let's see if I can move the steering wheel down. See, even the steering wheel is working. I'm able to move it down out of the way. There's our instrument cluster. We've got pretty much all the lights on, and our navigation is working. Looks like everything here is working too. Maybe the radio is working. Yeah, it's a bunch of static because it's not on the radio station. I'm gonna try to find a radio station, see if we can get some music here. 94.5. All right. Let's not get demonetized here. So as you can see, the radio is working. I'm gonna go ahead and put my foot on the brake pedal, and we're going to see if we can maybe start the vehicle. Well, nothing's happening, so we're still not able to start the vehicle or power up the ignition using the switch here. But I do think that now this is powered up, it's probably a good opportunity for us to try to communicate once again using our scan tool. All right guys, so I've got my J-box hooked up to the OBD2 connector. Again, we're powering up the interior. Let's go ahead and move over to the scan tool. Got the scan tool over here. Let's see if we can communicate, or at least if we can read the VIN. USA. Check that out. Now we have communication. Let's go ahead and hit yes. This is a 2014 and we are communicating. All right, so let's go over to diagnosis and let's go ahead and run a full auto scan on this thing. See what modules we're communicating with. As you can see, it is communicating with the engine control module. We have 2 faults already. ABS, VSC, traction control, we have 10 faults there. SRS airbag, 5 faults there. You can see we have a few faults here, air conditioner and EMPS. Main body we have set. In the main body we have 7 faults. Gateway we have 4 faults. Looks like the door motors, we have a couple faults there. Let me tell you, there are a lot of modules on this vehicle. We're already up to 28. Looks like we have a few fault codes here. Smart access, we have a fault code. Electric power control, we have a fault code. And there we have it. So let's go ahead and run a report on this, see what fault codes we have. All right, starting with the engine control module, we have a B279A. Looks like a TDS communication line high fixation. Then if we move over to the ABS, you can see we have a few different codes for the ABS. Looks like we have a code for open circuit, ignition 1, and ignition 2 power source circuit. We also have a brake booster pump motor on time abnormally long, pump motor relay, accumulator low pressure, capacitor communication malfunction, lost communication with ECM, PCM. There's quite a few different communication codes. Again, we may not be powering up all the circuits, so we might have some erroneous codes that are popping up. Also, don't forget this vehicle was flooded, so there's probably going to be some communication issues here. I think what we're really going to be worried about is trying to get this vehicle started. So looking at the airbag computer module, you'll see we have a few codes here. Looks like a system malfunction code, knee airbag, another system malfunction, passenger seat airbag, and then we'll move over to the EMPS, which, to be honest with you, I'm not sure what that stands for. But it says here we lost communication with the brake system control module. Then we have the air conditioner. It's like a damper motor control servo. There's quite a few other different codes. I'm not too worried about the air conditioner right now. Let's check out the main body. So at least we are actually able to communicate with the main body control module, because we're able to get some codes here. So if you look, we have a few codes: ignition 1 outside monitor, ignition 2 outside monitor, accessory monitor, LIN communication master, key collation, waiting time over, lost communication with C control module A, and the automatic high beam system. So then if we go over here, there's a gateway, lost communication with electric parking brake module, lost communication with blind spot monitor, lost communication with electric parking brake monitor, lost communication with intuitive parking assist module. And then we have some door malfunctions, which I'm not too worried about. Smart access says here, a communication malfunction between ECUS connected by LIN, the electric power control, saying here the IG2 terminal circuit low, lost communication with power steering control module, and lost communication with HVAC control module. So those are all the codes that we're showing. I'm going to go ahead and print this out, keep it for reference. But I think what I want to do real quick is I want to go into the engine control module specifically. All right, so while we're in here, I mean, there's quite a few different things we can check. We can check for live data. We can also do some active tests, see what we have. All right, so under active test, I mean, there's several different functions we can try to do. Just kind of looking through these. Well, check this out. We can actually activate the starter relay, which is probably one I'm interested in doing. So let's go ahead and try that. Because like I said, one of the things that I am really focused on is seeing if we can get this engine to run. So as long as the engine can run, then we know that you know, the rest of it is just mainly dealing with the electrical stuff. So let's go ahead and flick the starter relay on. I hear it clicking. Let me try it again. Let me try it again. Again, I do hear it clicking, but it's not turning. Almost kind of sounds like the starter is either stuck. I mean, it is possible that it does need a starter because, I mean, again, this vehicle was flooded, so it wouldn't be surprising if the starter motor was bad because it got full of water. So let me try to get down there and see if I can tap the starter and see if we can get it to turn over. All right, guys, so we just went underneath the vehicle and tried tapping the starter just with the ratchet like this. So we're gonna go ahead and see if we can crank it. Again, it just sounds like it's clicking, but it's not turning over. So it's possible that starter motor is bad. All right, guys, so check this out. So I was curious if whether or not there was a problem with the starter turning the engine, because to be honest with you, the sound the starter was making really sounded to me like it was struggling to try to turn the engine over. So what I wanted to do is I wanted to verify whether or not we didn't have something locked up, maybe a pulley or an alternator, because I mean, I've seen that before, especially with flooded vehicles. You know, we get water up to the engine, and what happens is you can get water inside the alternator, locks up the alternator pulley, and because the belt is on the pulleys, of course, the starter can't turn it. So anyways, I went ahead and I pulled the belt off, so you can see it's just kind of laying here. And I just kind of went down here, and I tried to spin the pulleys. So you can see this one is spinning. Look at this tensioner pulley down here is spinning. And this tensioner pulley right here is spinning, or excuse me, idler pulley. And the AC compressor pulley is spinning also. But when I came to this pulley right here, this thing is not turning. It is completely locked up. No matter how hard I try to turn this thing, it's completely locked up. So I thought, well, that's probably our culprit. You know, we just need to change that and we'll be good to go. But check this out. I've got the breaker bar on the crank pulley down here. And when I try to spin the engine over by hand, let me try to put all my strength and all my weight into trying to spin this crank over. Okay. That thing is not budging. That crankshaft is locked up. This motor is definitely locked up. All right, so the question now is, what happened? I mean, did the motor ingest water? It's possible that the motor took in some water. I don't know if the car was running when it went underwater. Maybe the engine sucked in water. I mean, that's really important to know because, you know, we could have a hydrolock condition, which means we might have a bent connecting rod. You know, we could probably pull the dipstick out and check the oil. See if there's water in the oil. Man, by the looks of this, it looks like they've already changed the oil. So if there was water in it, we don't know. So to be honest with you, I'm not even really sure if it's worth continuing. I might have to stop and call the customer because my service writer just told me that this motor used is going between $6,000 and $7,000. So is it worth putting $7,000 into an engine plus the amount of labor that it's going to take to drop this engine, replace it? And then on top of that, however many other electrical issues that this vehicle is going to have. To be honest with you, this may be a lost cause. It may not even be worth continuing to go any further. All right, guys, so I just got off the phone with the customer, and according to him, the vehicle was not running whenever it was flooded. So the vehicle did not drive into a flooded condition. The vehicle was pretty much just sitting. The engine was not running. The vehicle got flooded, the water receded, and that's what happened. So he did also tell me that at the previous shop that it was at, they told him that they were able to spin the engine over. So I'm not sure if they were lying to him or what the deal is, but apparently they changed the oil. So they must have seen maybe there was some water in there. So they changed the oil, or maybe they did it just as a precaution. I'm not really sure. Now, the only issue is that the car sat at the other shop for like 2 months. So it is possible that if there was water maybe pulled inside of one of the cylinders, or even in the oil, and the vehicle sat for 2 months, we could have a condition where maybe the piston ring rusted up and seized to the cylinder wall on one of the cylinders. So I mean, that's probably the next possibility. The guy really doesn't want to spend you know, $9,000 to put a motor in this thing. We really just want to see if we can get the engine to turn over and get it running. So I told him what we would try to do, and this is something that I've been successful at doing before. I'm not sure if it'll work with this, but what we can do is remove all of the spark plugs, and what we'll do is, if there's any water in the cylinders, we'll blow it out, and then what we'll do is we'll drop something into the cylinders that will dissolve the rust and unseize the piston rings from the cylinder wall. We'll just pour a chemical in there, we'll leave it overnight, and then in the morning we'll blow it out and we'll see if we can spin the engine over. If we can spin the engine over, then it was just seized up because the piston rings were seized up against the cylinder wall. So I mean, it's possible that we may be able to salvage this engine. I mean, I know it's not the best way to do things, but at this point, like I said, is it worth putting that much money into this vehicle, or should we just try to get it running? So I think that's what I'm going to try to do next. Let's go ahead and see if we can pull the spark plugs out. All right, guys, so I started removing the coils on this side so I can get the spark plugs out. But it'd be really nice if somebody could explain to me what's up with this. I mean, there's no room to remove these coils. And that back one, it looks like I have to pull the whole battery and the battery tray out just to get it out. Oh my God. Yep. I mean, I would really like to meet the guy who designed this. I just want to meet him, that's all. I would really like to meet the guy who designed this, because I just want to ask him a few questions about what he was thinking. All right, guys, so I was able to muscle 2 of the coils out, but this coil, no matter how hard I try to get this out, it will not come out. I mean, it is just jammed up against the strut tower here and this hole in the valve cover. So at this point, I really think that we're going to have to, I mean, as crazy as this sounds, but to get this coil out, I think we're gonna have to loosen the motor mount or something and maybe jack up the engine high enough so that we can get this out, because I'm telling you, this coil does not want to come out. Yeah, we're gonna end up breaking that coil trying to get it out, and that's not gonna be of any use, because then trying to put a new one in, we still won't be able to get a new one in. So let me fight with this, see if I can get these out. All right, guys, so we went ahead and pulled the spark plugs, well, at least 3 of them out of this side. If you look at the spark plugs, you can see that they're pretty wet with water. So I've got a borescope here. We're gonna go ahead and stick it down into the cylinder. I'm gonna show you what we find. So I'm gonna go ahead and start moving it down into the cylinder. There's a spark plug hole. Get past it. Kind of wiggle it in there. There we go.
Can't find the hole here.
And now, as you can see, that is the top of the piston, and there is definitely evidence of water in there. and it looks like we've got some rust going on in there. Let me switch the camera to the side view. This borescope has a side view camera. Ooh. And check that out. We are looking at the top of the cylinder. That is actually a valve. I'm not sure if it's the intake or the exhaust valve. Let me kind of twist this around. Oh, you can see the valve that's open right there. Let me try to focus in on it. That is the top side of the valve. You can see the valve seat. We have pretty extensive rust happening there. Rust, baby. And it's still pretty wet, with water. So if we make our way down the cylinder, you look at the cylinder wall, there's extensive rust down the cylinder wall. And if we get to the edge of the piston there, you'll see that definitely looks like the piston ring might be seized up against the cylinder wall. So this is just one of the cylinders. I'm pretty sure that we have more than one cylinder that looks like this, so I'm not even really sure if we can clean this up. We can attempt to, but honestly, this motor doesn't look good to me. So, all right guys, so with plenty of frustration, we were able to get all of the coils out and all of the spark plugs out. And what we went ahead and did was we took a mixture 50-50 of some acetone and some transmission fluid, and we poured a little bit in each cylinder. And now what we're going to do is we're going to let it sit overnight. Hopefully tomorrow we'll be able to turn this crank. I'm not sure if that's going to be enough to get those piston rings to break loose, but all we can do is try. Up. That thing's locked up. All right guys, so as you can see, the engine is locked up. At this point, we're gonna have to stop and call the customer and try to figure out what they're gonna want to do with the vehicle, whether or not they're gonna want to continue, because at this point it may not be worth trying to continue as far as the expense that's gonna be involved. Like I said, we did call around, and this engine is running around $6,500 for a used engine. And to be honest with you, I think the motor is really only one aspect as far as what could be wrong with this vehicle, because it is possible that if we replace the motor, you know, we could still have some other issues with the vehicle not starting or not running. Because right now, as far as I'm concerned, it's just kind of one of those things that's going to be us having to peel back layers, almost like an onion. You know, like an onion has layers. It's kind of like this vehicle. I think the more we continue with it, we're going to find that there's going to be layers upon layers of problems. So I really think that we've only really just touched the surface. This seems to me like it's going to go a lot deeper. I think at this point, it's also a question of whether or not I want to continue with it, because I really feel like I'm going to spend a lot more time on this vehicle than it's probably worth for me. So like I said, at this point, I'm just going to have to call the customer. We're going to have to come up with a plan, and he's going to have to decide whether or not he wants to continue with this. So I'm going to talk to the customer, and we're going to see what happens. All right guys, so I did talk to the customer. It turns out that he's pretty adamant about getting the vehicle fixed. I think at this point it's probably one of those things where he's got so much money sunk into it that he really can't turn back. So what we're gonna try to do next is we're gonna try to source probably the least expensive engine that we can get, just to try to get this thing up and running. So we are gonna be on the lookout for an engine, but in the meantime, we're not gonna let the engine slow us down or stop us from continuing our diagnostic, because we still need to get the ignition to power up on itself. As you guys recall, we were able to manually power it up using the power probe, but the goal really is to try to get this thing to power up by being able to utilize the push start. So let's go ahead and move back to the vehicle and finish up with our diagnosis. All right guys, so moving back to the vehicle, as you can see, we've got the interior powered up. Again, we're using the power probe to manually power up the main body ECU in order to power up the interior. But we are able to communicate using the scan tool now. And if you recall, we did a code scan, and we found multiple codes. So I think what I want to do at this point is I'm going to do a quick erase on all of the fault codes throughout all of the modules, and we're going to see which codes pop back up immediately. So we're just going to go ahead and quick erase, and this is going to erase all of the codes in all of the modules, and we are going to concentrate on the codes that come back up immediately. Those are going to be the hard faults, and those are going to be the ones we want to concentrate on. Sorry about the beeping in the background. That is coming from the interior of the vehicle. I'm not sure why it's beeping. It is pretty annoying, but there's really nothing I can do about it at this point. It just seems like as long as we have this interior powered up, it's going to continue to beep. So, all right, guys, so we finished with our quick erase. Let's go ahead and run a report, and we'll see what codes we have. We're going to start at the powertrain control module, or the engine control module. Okay, here we are. We're going to start at the engine control module. We have 8 faults, and if you look, we do have the intake air temperature sensor circuit code. We have a couple of these. The reason behind that is because we have the air box removed. Again, we went to remove the coils, so whenever we remove the coils, we had to remove a lot of the pieces on the front of the engine. So you can see we have the mass airflow sensor disconnected. So we're probably going to have some codes for the mass airflow sensor or for the air intake temperature sensor. We're going to ignore those. Let's see what else we have here. We have this B279A. That's going to be TDS, communication line high fixation. That I believe is probably going to be a really important code because it may have something to do with either the CAN bus communication system or some type of module to module communication. So we are going to save this code. Let's go ahead and pull up the code description on this and see what this code is all about. All right, guys, so we're here at the computer. I've got all data pulled up, and we're looking at the code description for B279A. It says here, theft deterrent system, communication line, high fixation. So if we look here, it gives us a little description. It's telling us if the communication line, which is designated as EFIO and IMI to the ID code box, is stuck on high output. So it's basically saying if the communication line to the ID code box is stuck on high output, then the ECM outputs this DTC. So now looking at the detection condition, it says here when communication line between the ECM and the ID code box is stuck on high output. So it's pretty much telling us the same thing it was telling us here. And if we look over here at the trouble area, this is going to give us a few possibilities as to where we could be having a problem. So it says here harness or connector. We could also have a problem with the ID code box, or we could have a problem with the ECM. Now looking over here, you'll see that we have a wiring diagram. Let's go ahead and zoom in on that wiring diagram. Let me bring it over and get a better look at it. Okay, so looking at this wiring diagram, it's pretty straightforward. We have 2 components here. We have the ECM on this side, which is the engine control module. And on this side, we have what's called the ID code box. This is going to be a security or anti-theft module. Now, if we look at the circuit, it's a pretty simple circuit. We have this communication line that ties the 2 modules together. And if you look at each module, this communication line is designated as either EFIO at the ID code box, and at the ECM, it's designated as IMI, which I believe is probably short for immobilizer, but don't hold me to that. Anyways, what the code description is telling us is that whatever signal that's going back and forth between these 2 modules on this communication line is at high fixation. I'm not really sure if the ECM is sending out some type of reference voltage to the ID code box, and then the ID code box is supposed to ground that reference voltage, or vice versa. Maybe the ID code box is sending a voltage out to the ECM, and then the ECM is supposed to ground it. I don't know how communication happens between these 2 modules. It doesn't really tell us in the code description, but I'm assuming that using a lab scope, we should have some type of waveform that we should be seeing at either the IMI pin or the EFIO pin. Now, if we look at this diagram, we also see a few other important things that probably need to be checked. If we look up here at this pin 1 at the ID code box, you'll see that that's going to be a battery power plus or battery voltage source. And it says here that that battery voltage source comes from the security fuse. So I believe that's going to be the main power that powers up this ID code box. So that's going to be one of the first things that we're going to want to check, is to make sure that we're getting power to the ID code box. And then if you look over here at pin 8, there's a ground. So that's going to be important as well. Also looking over at the ECM, you'll see that we have another ground, which is going to be something else that we're going to have to check. So all right, just to give you guys an idea of the location of the ID code box, I have this diagram pulled up. See here it says ID code box, and according to this diagram, it's located somewhere behind the instrument panel, I believe. Looks like above the steering wheel. So let's go ahead and move over to the vehicle and see if we can find it.